Hi students, this is Berila from Aurum Engineering College. Today we are going to see the linearity property for both discrete time system and continuous time system. So the linearity property, the procedure to verify the linearity property of CT and DT systems are: the first step is to consider two input samples x1 of n and x2 of n for DT system if it is CT na x1 of t and x2 of t, and find its corresponding output y1 of n and y2 of n. Step 2 is the linear combination of outputs to be found: a into y1 of n plus b into y2 of n. Step 3, find the output y3 of n for the linear combination of inputs. So that is y3 of n, which is nothing but a into x1 of n plus b into x2 of n. So y3 of n is the linear combination of your input. So here we have to x1 of n and x2 of n. So this x3 of n is nothing but a into x1 of n plus b into x2 of n. For this x3 of n, we have to find the y3 of n according to the problem statement. And 4, if the linear combination of output is equal to the output of the linear combination of inputs, the system is said to be linear. Else, the system is said to be non-linear. So, we have to be very careful while you are finding the step 3. So let us solve a problem in CT as well as DT. If n is replaced by t, we will be getting the procedure for CT systems. So determine whether the given discrete time system is linear or not. So y of n is equal to x of n square plus x of n. So step 1 is to consider two input samples x1 of n and x2 of n and find its corresponding output y1 of n and y2 of n. So according to this problem, the y1 of n is equal to x1 of n square plus x1 of n, and y2 of n is equal to x2 of n square plus x2 of n. And step 2 is to find the linear combination of output a into y1 of n plus b into y2 of n. This step is very simple. So a into y1 of n plus b into y2 of n. So this y1 of n will be replaced by x1 of n square plus x1 of n, and y2 of n is replaced by x2 of n square plus x2 of n. So a into y1 of n plus b into y2 of n. So while substituting the third step, we should be a little bit careful. So third step is find the output y3 of n for the linear combination of inputs. So where your input is x3 of n is equal to a into x1 of n plus b into x2 of n. So this value will not change. So for this input, you have to find the corresponding output y3 of n for this particular problem statement. So according to this problem statement, I can write y3 of n is equal to x3 of n square plus x3 of n. But your x3 of n is given by a into x1 of n plus b into x2 of n. So this x3 of n square can be written as a into x1 of n square plus b into x2 of n square plus your x3 of n is nothing but a into x1 of n plus b into x2 of n. So step 4, I have to check whether the linear combination of output is equal to the output of the linear combination of inputs. So here this is nothing but a into x1 of n square plus a into x1 of n plus b into x2 of n square plus b into x2 of n. So which is nothing but both are equal. So the system is said to be linear. So we can see one more problem in CT system. So y of t equal to x square of 2t. So this x square of 2t can also be written as x of 2t whole square. So for this one, consider two samples x1 of t and x2 of t. Find its corresponding output y1 of t and y2 of t. So y1 of t is equal to x1 of 2t whole square and y2 of t is equal to x2 of 2t whole square. So find the linear combination of its input. So y1 a into y1 of t is replaced by x1 of 2t whole square and b into x2 of 2t whole square. So here the linear combination of your input, as I said earlier, your x3 of t is going to be same, a into x1 of t plus b into x2 of t. If this is going to be your input, according to the problem statement, y3 of t is equal to x3 of 2t whole square, where x3 of 2t can be written as a into x1 of 2t plus b into x2 of 2t. So it's whole square. So here it is nothing but a plus b whole square. The formula is a square plus b square plus 2ab. So here this is not equal. So this is only a into this square plus b into this square. So here the whole formula square, they have additional of two terms. Along with that, here it is a, here it will be of a square. So the function is not same. That is, since the linear combination of outputs is not equal to the output of the linear combination of input, the system is said to be non-linear. So while solving the step 3, you should be a little bit careful to get your answers properly. Thank you, students. This is for today's class. You can subscribe the channel for the automatic updates. Have a nice day.